We're good. Yeah, we're good. So as far as time, I'm still there's 2 minutes left. Yep. Okay. So I think we'll go ahead and get started. Thanks for coming out. My name is Casey Smith. This talk is about how to build a Canary token to monitor Windows processes. How many of you have used Canarytokens before? Some of you? Okay, so some of you, this will be new. Just a blurb about us. Myself and Jacob, we're on the research team at Things. We're on the applied research team. So really our mission is to try and help folks find problems to, or solve problems that companies have. And so Canarytokens is one of those. I'm on Twitter sometimes at @subT if you want to connect with me. I'll post the slides and stuff later on GitHub as well. What we're going to talk about today is really what is a Canary token, how they're used, a lot about research. So some folks ask a lot how to get into security research, and we'll talk about pros and cons and sort of the life cycle of researching these things. And really the heart of this talk was a command execution alert. So like for a really simple system, like think of a school or a hospital or nonprofit, they don't have EDR, they don't have a lot of SIM logging capability, but they might want an alert if somebody runs KList or NL test or some of these obscure commands that show up in ransomware. So the idea was we used a red team or offensive tool, debugging tool to be able to do that. And we'll take you through how that process worked. And we'll take you from idea to delivery, because there's a lot of folks out there, we have a lot of good ideas, but a lot of it in research really just hits the floor and never makes it to a product. So we'll talk about how do you move something from like a cool idea to actually something that people can use, whether it's code or a product or tool. So just a quick word about Canarytokens, because I think this will set the stage for what we built. Fundamentally, Canarytokens are free open source. You can get the server code online. GitHub, they're simple objects, so Word documents, PDFs, QR codes, AWS credentials, Azure credentials. The idea is these are artifacts, and if an attacker opens them or uses them, you get a really quick alert. So definitely try it out after this. Canarytokens.org generate. We'll create the free tokens. You can also fork that repo or run it inside your own Docker container. A lot of people do that because they don't want the Canarytokens.com domain inside of their trigger. So super cool stuff. The primitives that we use are DNS and HTTP. So if we can get an attacker or someone that's taken your artifact to do a DNS lookup or HTTP lookup, we can get an alert, and that would give you an indication that somebody has both taken that document and opened it remotely. So we'll talk about encoding. We use some offensive techniques to encode data into our DNS channel, so you can get things like a username and host name that opens your executable or file. So they work really well. We'll definitely test them. Our theory is they work. We've got good feedback, but always open to people testing it and finding the boundaries. So if you went to the site, you could just go and choose to create a token. Like I said, the primitives are web or DNS. I think I could zoom in here a little bit so you can kind of see AWS keys. We're talking about the sensitive command token, but there's other documents, Excel, Word, etc. So. And if that document opens or if somebody uses those AWS credentials, you get the alert that somebody opened it, and you get a little bit of context, like maybe source IP address or whatever memo you put inside of that Canary token when you actually built it. So again, attacker uses a token, you get alerted. So that's the background. That's what a Canary token is for. We wanted to add a Canary token that actually alerted, say, if somebody executed a command on an endpoint. So as far as the research approach, wanted to share a little bit about our thinking, how we approach research and solving problems. So a number of you have done research, but there's this life cycle where you have this initial idea, you get really hyped up that this is going to be the thing, Nobel Prize, whatever. Then you actually start thinking, but I don't really know how Windows works. And so you hit sort of the trough, and then eventually you come to this middle ground. But I just wanted to share that because a lot of times, a lot of people get frustrated because they get into that trough and they don't really push through. And so there's different researchers' approaches. Like DARPA will have a thing where they'll say, like, what are you going to do when you hit your first hurdle or first big set of resistance? How are you going to push through that? And you really have to be committed to that idea as opposed the idea or the outcome as opposed to your particular method. And I'll share a little bit about that. Like on the left-hand side, we had a ton of ideas about how we could alert on an executable, and 5 or 6 of them just didn't pan out because we didn't like how it worked. It wasn't easy enough, et cetera. So things like scheduled tasks or Windows event log or DOS key, There was a number of failures along the way, so I wanted to make sure I included that just so you get the sense that a lot of people that do research, either privately or for organizations, experience that same life cycle. The other thing I'll just mention is the fragility of early ideas. One thing you can do is really catalog these, because you may have an idea and you may not actually come back to it for a couple of weeks or months. But it's important when you have that spark or that idea, put it in some notes, put it in a Slack channel, and also be careful when someone brings you an early idea of popping that bubble too soon, because sometimes it's not well formed, but that idea or tip off may be the thing that leads you to great ideas. So just handle those very carefully. Don't want to shoot things down, but also keep track of it in case you need to come back to it. So in terms of collaboration, we use a lot of Slack. We use whiteboards, asynchronous. Most of our team is in South Africa. Jacob and I are in Colorado, so we use a lot of async. We also use Slack to record things like, hey, here's maybe a 2-minute demo of something I'm thinking or prototype. Those can be really helpful. Record it, write a note, create a markdown document to keep track of it. But always getting other feedback from other folks is going to be very helpful. Okay, so that's a little bit about like our research approach. Now let's talk about what we wanted to build. So the command execution alert was really the hypothesis here was, could we build a simple token that would alert teams if somebody executed a command? And so I borrowed a lot of the skunkworks imagery here for the F-117 and stealth fighter. But how many of you have read DFIR reports? Some of you have read some of this. Okay, so if you haven't seen their website, these are really great. They're very detailed write-ups about intrusions. And so this is an example of a quantum ransomware. And in almost all of these reports, you see these chains of commands. Okay, so you see system info, NL test / domain trust, all trust, net view. So the enumeration phase or discovery phase, very often attackers use commands that are already built into the system. They're not necessarily using malware yet. This is what we wanted to try and understand. Now, we wanted to do without having log analytics and EDR and installing a sensor. But if somebody runs NL test, a pretty rare command, or klist, honestly, we would want to alert on that. So especially in those smaller environments, if somebody runs that at a nonprofit or a school, how could they get that alert that somebody is running commands they shouldn't be running? So again, you read these ransomware reports. That was the genesis of the idea, was, well, could we actually build something? Who legitimately runs NL test trusted domains? Some of you have that information in your networks. You have tools that do command line auditing and process execution recording. Other organizations don't. So a good idea as you use this token is to profile or understand your organization and the commands that run. So again, we see this continually. We see all these different, every time you read reports, you start to notice it. There's common themes like NL test, trusted domains. You know, that's something this particular group does to enumerate Active Directory, klist, other utilities. Who runs NL test legitimately in your day-to-day operation on Windows? Anybody? Yes. You know, impromptu sample. Nobody's probably running that tool. Could be an indicator of early compromise. So we see those commands. How can we create the simple alert? That's the hypothesis. That's what we're trying to help folks detect. So a lot of trial and error and prototype. So this is what I wanted to show you here. The plane in the lower right corner was called Have Blue. It was the early prototype for the stealth fighter. But you get the idea. We have to build something to test our theory, and that's where we're looking at in this. So how do we go from I have this cool idea to actually something people are going to use or actually detect adversary behaviors? So we have two requirements. Our minimum bar is it has to be easy to deploy and low false positive. If it doesn't hit those two outcomes, it's not interesting to us. So that's just our philosophy for Canarytokens. We don't think people will use it unless it's easy to use. And if it creates a ton of noise, people aren't going to use that as well. So again, we're not saying here that you can replace your EDR or SIM or other analytics like ProcMon or Sysmon. But hopefully this will give you a high fidelity alert if somebody runs a command you're interested in. Some commands are better than others. We'll talk about that later on. Like who am I? You might have a theory that never runs in your environment. It probably runs more than you think, so probably not a great candidate for this token, but NL test might be. So the first thing we tried was DOS keys. Anybody heard of DOS key before? Some of you have seen this. So DOS key is this old Windows technique that you could alias one command. So you could basically say, D, and then if you type D, it effectively runs a command like dir/all or something like that. So it actually had some early promise. And so if you're curious, there's some like macros or aliasing commands. We thought this would be perfect. We just alias NL test and make it send an alert or fire notepad or some PowerShell script. The problem with DOSKey is it doesn't persist across all users, and it doesn't persist or present inside of like an RDP session or something like that. So we really liked it. It showed us that there's a potential pathway or outcome we could get, but it didn't meet our requirements. But here's an example of how you could run a DOSKey command. And so we're saying here, if you, instead of when somebody runs scheduled tasks without .exe, then we're saying change that to run scheduled tasks. And then if you notice, there's a couple of and signs, and also run notepad in the background. So that actually worked, right? It was cool. You would run scheduled tasks. You would not tip off the attacker that you've aliased that command, and you could fork and run something in the background. But again, I talked about some of the reasons why this one ran, but it was very important to us that this kind of gave us that light, like there's probably a way to do this. DOSKey turned out not to be the way to build it, and I mentioned that earlier. So it doesn't work because it doesn't show up in RDP, and it also doesn't work across all users. So we really wanted something for anybody on that system running any command. So put that one on the shelf. We'll go back to try another technique. Some of you are familiar with this. How many of you are familiar with 4688 events in Windows? Okay, so this is essentially a process execution event. Gives you like the parent process. It also gives you a little bit of detail of the command line and the executable and path. We thought this might actually be a way to do it because you can actually attach a scheduled task to an event. Some of you may know that, some of you may not. It's a cool technique that offensive teams have used for a while. So you can say, if I see an event 4688 that meets this criteria, then you can just literally inside of Event Viewer say attach a task to this event. It'll run PowerShell or run some other command. Very sneaky persistence that could work. So we thought this might be a technique that would work as well. Let's see what happens if we see the command or process. The problem is now it's like per event. So you'd have to have a filter that would say every 4688 event, I'd have to crack that open and look at the properties and see, is it the process I wanted? Is it the command lines? So again, it doesn't hit our bar of being simple and easy to use, too many moving parts. To deploy this on all different machines, you'd have to create that task and assign them. So while it could work, it didn't meet our criteria. So you're stuck. We tried DOSKey, we tried some event logging. We looked at a bunch of other techniques, WMI and a few others, but none of them hit our bar. So some really good questions when you're doing research is ask, what would a developer do? And also ask maybe what would an attacker do? And that actually led us to a pretty cool breakthrough where we were like, hold on a second, what would a red team do to alert on execution, or what would they do to trigger some notification if their binary executes? So some of you are familiar with this registry key image file execution options, i.e. FEO. And Advar had this great blog, huge shout out to Advar, but he wrote up this tool. He could use IFEO to run his malware to evade auto runs detection. So at the time, I don't think that the sysinternals to auto runs detected this. So that got us thinking, could we use that red team technique to alert? And sure enough, it did. Now it's going to still need a little bit of refinement, but there was our breakthrough moment. And actually, what's not in the slides is it kind of sat in our Slack channel for 2-3 weeks. Like we tried DOSKey, we tried WMI, we tried event logs, nothing was happening, just shelved it. And then just you have one of those moments where you see something or think of something and you're like, okay, maybe this will work. So what I want to do now is take you through how this IFEO registry key works and how we repurposed it, a debugging tool to alert on an execution of a Windows process. So you can read about all this. It's online on Microsoft's site. The command that you're using is silent process exit. And what that allows you to do, think of a developer. So their application crashes and it automatically runs and attaches a debugger to that process. So we're going to repurpose that and say, application we're interested in runs NL test, run my canary alert. Same thing. The reason we like it is it's built into the operating system. It's supported. It gives us a lot of flexibility. So some things that we ran into, it wasn't like an immediate win, right? So you have, maybe I want to try NS lookup. That was our first approach. So someone runs NL test, and then silent process monitor executes NS lookup for a DNS token. Or maybe we use PowerShell to resolve the DNS name and then give it the token to do the alert. The problem is we were trying to get information about, it's not enough to tell you, like if you have a DNS token, it's not enough to tell you where it ran. All you know is someone used this resolver to look up your DNS token, and that's really hard to trace back to an actual endpoint. So what we wanted to do was have something like the environment variable computer name, the environment variable username, plus your DNS token, and that would actually trigger it. But it was failing, so we couldn't figure out why. And if you go back and read the docs I showed earlier, you'll notice there's a couple of variables. It's kind of hard to see there, but there's a %C status code in the documentation that actually gives you information about the exit thread. So what we were having was when Windows parses that registry key, if it finds a %C like it did inside of our %computer name, we had a collision and we couldn't find a way to escape it. So we were stuck with, all right, so NS lookup is not going to work for us. So we ended up having to settle on command runs, and then we'll do a PowerShell lookup. So in effect, what you're able to get then is someone runs NL test, you get the username and computer name in the DNS lookup, and I'll take you through how we did that in a little bit. But just to show you again, there's always those little things where you think you might have the problem solved, you'll hit friction along the way or things that might interrupt what would otherwise be a cool approach. So some of you may know this with DNS Canarytokens, some of you this may be new, but you can encode information into the DNS lookup. And so the Canarytoken subdomain will be like randomstring.canarytokens.com. So if something looks that up, you get an alert, somebody just found that. And that's important for things like QR codes or other tokens that you might use. But you can also base 32 encode that information and chunk it up into parts of the subdomain. Why base 32, not base 64? Anybody know? Why wouldn't you use base 64?
Slashes.
Yeah, there's some characters that may not be accepted, and also case sensitivity. So what you run into is you want these to be not case sensitive, whereas a base 64 encoded string would be case sensitive, and there's no guarantee that that would come through in your DNS. So kind of a cool thing, but you can actually encode this information and put like messages or like a lot of C2 DNS. We use this. We also use random characters to prevent caching and use a low TTL. So the last thing you want is some like threat intel source to look up your DNS and you get the alert when it actually wasn't bound to the event. So the other thing you'll run into is like spaces and non-Unicode characters. So I'll show you in a little bit, but if local service runs your command, if that account, or if you have an account that's privileged that has a space in the name, you're going to need to concatenate that and reduce those so that it actually goes into your DNS lookup. And we also always put a character like U or C in there so that if it doesn't resolve for some reason, it won't break the lookup. So again, some caveats, not a replacement for EDR SIM, but essentially now we've got a way to create a token that will alert anytime something executes. You don't want to use PowerShell or command. Those will cause infinite loops, and I'll show you why. But again, for some small organizations, it's a pretty fun way to trigger the alert. So some things we had to deal with. It is actually an attacker technique, right? So when you install this registry key, it looks very much like something that malware might use. So you might get an alert from Defender or CrowdStrike or something like that. Be aware of that, but as long as you know where that registry is going and that you've provisioned it. The other thing that's kind of cool is, or sorry, not cool, but interesting, is some commands aren't as rare as you would think. So again, you might think, who am I? Would be a good one. Might work in like a build system or a process that's ephemeral or a server that's ephemeral, but it may actually run in the background more than anything. So other things just to be aware of, the name of the executable might be available, or the username or host name are. We're not encrypting those on the network, so that's in the lookup. If you're worried about that, probably not a good token to use in those situations. So at this point, the research is done. We have a way forward. Now let's talk about how do we turn that into something that actually goes on Canarytokens.com that a user could download and install. So again, if you read the history of the stealth fighter, they originally put that wooden prototype on a pole and they hit it with radar and it took the size of the plane to like the size of a golf ball on radar. It's pretty cool. And then they had to build something that would actually fly, then they have to build the final product. So just borrowing that idea to actually working our implementation. So again, the things that we want to do here is first choose a command to monitor. So you're interested in a command that runs rare. Some bad or things that are not good candidates are PowerShell, Outlook. You typically want short-lived processes, right? So NL test, ipconfig, maybe that probably runs more than you want. Who am I? Then the next set of criteria is you go to Canarytokens.org, you would create the command, and then you would put yourself a note or a message so when that alert triggers, what are you going to do with that Canary token? And then lastly, a couple of caveats. It does require administrative rights to deploy the registry key, but you can create one registry file and deploy it to all the machines because it dynamically picks up hostname and computer name, one registry key per command you're interested in monitoring. The other thing that's interesting is it works even if the file is not present. So let's say your organization never uses psexec. You can build this token, import it, and if psexec runs on any machine, you would get the alert. So even if it's not installed, the attacker brings psexec, you would get the alert. If they rename it, the name has to match. So again, it's not perfect, but it would have to be psexec.exe. And a lot of times attackers bring those, they don't rename tools, they keep the same name. So we've still seen it be effective, but just be aware of the edges of the capability. So just to take you through it, you would essentially go out to Canarytokens.org. The command you're going to choose is you would choose your sensitive command token, which has the little registry icon. You'll put in an email where you want the alert to go to. You can also send that to a webhook. So if you don't want an email, you can also then put in a note here that's what is the purpose of this token. And then you would put in the name of the binary you're interested in monitoring, nltest.exe. Hit create the token. Now, this is why some people like to run their own token servers, because this is on our website that we run for free, but you could also host your own as well. Again, now you would have a registry file that you would download to import. So let me take you through now the guts of that registry key and see how that works. So when you create that and download it, what you'll get is a file like this, and it's ready to be imported with just reg.exe space import. There's really three keys that we set in there. The first is image file execution options. And we're setting a global flag there of 200. I'll explain that one in just a minute, but that basically says use the monitor silent process exit. And then we set that to be reporting mode to 1. And then you can see down here is our PowerShell, which I'll take you through. So if NL test runs, that PowerShell snippet will run, get the username, computer name, and then send you an alert over DNS that somebody's run that command. So the 200 is just essentially the code that says inside of your global flags, enable the silent process exit monitoring. Again, it's a debugging technique. You want to double check and make sure you don't have other processes that have that already set in your environment. In our testing and research, it's been actually pretty rare. Next, you're going to set the flag for reporting mode to 1. There are other keys in here, though, that are kind of interesting, especially those of you who do offensive research. Local dump is interesting because when that process runs, it will create a memory dump and also a notification. So it would silently kill the process, but maybe a pop-up down by the clock. I don't know that that would be useful maybe for putting information for the user if you're debugging. But the one we're interested in is this process runs, and as soon as it exits, I want to attach another process to it and do a thing. So that's really what we're repurposing. All of this screenshots are just from the Microsoft documentation site. Okay. Now, these were the things that you can also use, some other parameters. So we've had requests from customers and folks that are like, hey, could we also get the parent process, or could we also get other details? You can. Like %e will actually give you the PID of the process that was running. So if you wanted that for logging, our default token doesn't have it, but you could just as easily get that, and then you could go look up that process or look up the provenance of that process, the heritage, whatever. But I leave it to you to explore. We're not using any of these variables. But you may also want to get the command line. So, like for example, some people are only interested in ipconfig.exe if it runs with /flush DNS. So you'd have to customize the token, but we absolutely have seen people do that. So every other version of ipconfig is fine, essentially. So what we're able to do then is repurpose a debugger, persistence, or attacker technique, and then we can notify us on execution of that particular event. So now let's break down the PowerShell command. So we have, if you notice in that blob, the process we run is command, and then we run PowerShell. And we have a little bit of redundancy here, but what we don't want to do is tip off the attacker that they just ran NL test and have a message box popping up so that they stepped on a tripwire. So it starts a hidden window and reduces doesn't show the pop-up. So it silently runs in the background. The other thing that's cool is NL test still runs. Whatever command they actually ran is fine. It's just the alert comes to you in the background. And so this is essentially the PowerShell command broken down. Inside of here, you can see line 1, we just run hidden window. And then you'll notice a few things in here. We're using PowerShell with the username, and we append a U so that for some reason that doesn't resolve, it will still get to the server. It'll just have a U, you won't have the username. But what we don't want to have is we want it to fail and fail with some information as opposed to failing and not notifying you at all. The rest of that command is essentially removing non-ASCII characters that might be in a username or in a host name. And then lastly, then we would essentially run the command %C for the computer, or I'm sorry, $C and then $U, and then we would have the unique DNS name for that token. So because it's just PowerShell, you can put whatever you want there and say line 3. You could customize it for your organization. But in the end, we see this working, and then you would see at the bottom there, when the command runs, this is the DNS lookup. When that hits the Canarytoken server, then you actually get the alert that that command was executed. Questions so far? Is this making sense? Interesting? Okay, all right. So again, you've gone to canarytokens.org, you've created the registry file. At the top there, you can see you're just going to simply run reg import and then the name of the file, and you can deploy that onto other machines in your network. And then you can see here on the left, nltest.exe runs, and in the background, there is a lookup for the unique username, host name for your unique Canary token, and you get an alert. Now, I'm presenting from the iPad, so I can't do a demo, but I could, maybe after this, if you guys want to see the demo on a Windows machine, I can show you out in the lobby there. But what you would get is the alert, and effectively the alert would have information here about the reminder you created, the type of token, and the source IP. Now, be careful with that. That's not the source IP of the host. It's the source IP of the thing that did the lookup. So because it's a DNS lookup, it doesn't go directly back to the host. But you would get down here in the alert, you'll see Casey ran NL test on the computer KCC69. So that's the username and host name that goes into the alert. All right. You get some additional information. This is one that we did earlier this year, a demo, but you can see there, that's what it looks like as far as parsing it out inside of your alert. Again, you can do a webhook, you can do other places to send that alert. And it usually just happens within usually just within a few seconds of that command executing, you would get that notification because DNS is so fast and DNS exits most networks. It's pretty reliable as far as getting out. To validate or test, so before you deploy this, you can check some things in your environment. 4688 events are free. Definitely turn those on. It gives you a good tracks that you can follow in the network without spending anything else. You can turn that on in Windows, but you'll actually see validation that the command executed. And also for those of you that are doing threat hunting or additional research, this technique also creates an event log 3000 ID. So whether that's a defender using this token or an attacker using this approach, you would see some pretty good trails in the logs of that execution event. So you can see there, event ID 3000 is a process exit monitor, which you've set in the registry associated with that command. So you would see in this case, I have one for net. You can do one for net.exe, net1.exe, again, just be careful. Those may run pretty frequently in your environment. All right. Here. The other thing that's interesting that we ran into that we didn't know about right out of the gate was this is dependent on Windows error reporting. So if your environment has Windows error reporting disabled, you would need to turn that on for certain hosts. So the underlying substrate for this particular alert and debug mechanism does depend on Windows error reporting being enabled, which it is in most environments, but there are places where that is turned off because that telemetry does stream up to Microsoft. So you can validate that in terms of enable or disable or, excuse me, use get Windows error reporting to check the status. Talked about this already, administrator to install the token. The nice thing here is any user that runs the command, you'll get the alert. So you put that, install that one time as administrator. If it's a jump box or a build box, anything, anyone that runs the command, and then any execution creates that DNS alert for you. Use cases, again, just remember, like Outlook.exe is not a good example because people open Outlook and it stays open all day. You don't get the alert until the process exits. So that's where like the enumeration commands are usually helpful. K-list, NL-test, etc. So again, some other metadata here. Lightweight doesn't. Just a reminder, doesn't replace like EDR or other process monitoring, but it also works even if the file isn't present. So like a super simple one, it's not a great example, but like wmic.exe, right? Like an attacker brings that. Very rarely do they change the name. Some do, some advanced teams do, but they run that thing, it should never be that name and run, you would get an alert. Or ps.exec is probably more commonly used, something like that. So this is what I was talking about earlier. So some of the enhancements. So let's say you're only interested in who am I if they run whoami/all. So the token by default doesn't have this in it, but you can easily prepend that with some logic. And so if you remember earlier, I told you there's like %e gives you the pin. So what you can do is use this PowerShell statement to say, give me the process ID with WMI, where the process ID was %e, and then it will go, and then you just say select the command line. And now, once I know the command line, I can put a filter decision. I could say if the command line contains /all, then I want the alert. Otherwise, I don't care. So again, know your environment before you turn those off. I'm just trying to show you, you can really customize that token, customize that registry key to something that's unique for you. So kind of a cool thing. It's been helpful. All right, so I think we're doing okay on time. Hopefully it didn't. Yeah, we're doing good. Okay, so again, closing thoughts. So the idea here is we took an offensive approach, repurposed it for defenders, using both DNS encoding and also that registry key. So always good to know what offense is up to. They have the great ideas that are usually very clever and innovative. So, and then one registry key can deploy that to any machine. Give it a try, like test it, give us feedback on how it's working. Shout out to the team. Again, it's never a single person that comes up with an idea and lands something. We've had really good feedback from folks, but again, to go from product to idea to something you put on a website, it's quite a journey. Hopefully you got a sense of that in the talk here. And then these are some books that we like. I'm a pretty avid reader. Has anybody read the Skunk Works book by Ben Rich? Awesome read. Ben Rich and his team worked on both the U2, the SR-71, and the Stealth Fighter. So really cool history and really cool intersection of like idea and prototype to engineering, and something that you have to actually work on and support. Very good stuff. The Right Kind of Crazy, also a good book about building Mars rovers and just that intersection of ideas, innovation, and engineering. And then Loon Shots. Those are just some really neat books about like history and other places where you'll encounter that. Reading outside of security domains is usually very interesting and helpful. And with that, I'll leave that slide up. We've got maybe a couple minutes for questions, but I want to make sure we turn over the room for the next speaker. So maybe 2 or 3 questions. Otherwise, I'll turn you loose. Questions, comments, feedback?
Will the slides be available?
Yeah, I'll post them. I'll post the link and make sure everybody has access to them. Yep.
This is the link, or?
That's the link for where you would go to create the token. I don't have a link in the slides. I'll just sub to you on Twitter. I'll tweet out a link a little bit later. So I'll post it somewhere for full. So. All right, well, thank you for your time and attention. Thanks to the folks. volunteers and everybody helping with the conference. So have a good time.
Oh my goodness. You ever run into situations where you're getting something wrong? So if you have a username, name on there.
Yeah, so yeah, no,